One last word about color and the way we see. To do that, there is a set of simulation that I put together from a colleague out of Taiwan that I'm going to go over. Okay, they are at the site shown there. I'm going to go directly to the site right now. Okay, right now we have a picture of a mouse and some circles, and we see them because we have the light that's on. If we turn the lights off, we don't see anything. What's the message here? We see objects because of the light that is reflected off of them. Actually, we see objects through light that's reflected off of them, light like coming from this light bulb in this case, or coming from the sun if we are outside, or we can see objects if they emit light like the light bulb. Now, even us, we emit some type of electromagnetic waves. We emit actually light at the infrared range. And one interesting thing is the frequency or the wavelength at which any object emits light. It's going to be correlated or related to the temperature of that object. For example, when you look at a light bulb, it emits in the white kind of spectrum. It emits the white spectrum or the white wavelength, visible spectrum. The surface of the sun emits at the same wavelengths. So actually, the temperature of the surface of the sun is the same as the temperature of the filament in a light bulb. Actually, one of the things that people do to measure the temperature of hot objects is to measure the wavelength of the light they emit. Now, in our case, we emit infrared, and that's why people can see us when they wear these infrared goggles. Now here we have spotlights, red, green, and blue. And actually here, if we remove the red, we can click here, remove the green, and we have only the blue. We are trying to look at our Mickey Mouse with just blue light. Now, one thing you'd like to notice is only parts of the Mickey Mouse that can reflect blue are the ones we are seeing. The other parts are absorbing the light. Actually, we are distinguishing them just because of the blue. Notice here, when I have the light away, we don't see the edges anymore. Now, Mickey in this case is absorbing all blue lights here. He's reflecting blue lights here. Now, if we don't use the blue and use the green instead, he's also reflecting green from those areas. Okay, we can make it stronger. And okay, let's go fully stronger. Now if we go to red, you'll also notice he's reflecting red from here, but not from the other top ones. So what does that tell us? If we have all lights, and when we add all the lights, you see the color of the eyes. When we add all the lights, the tells us of the color of the ears. When we add all the lights, that tells us of the color of the mouth. And you see the color of the face as well when we add all the lights. It tells us that the color is red because it's reflecting the red and it's absorbing the others. Okay, now the way colors add up, it can be added up like pigment. Now here, when we shine light beams in a dark room with these colors, that's the way they're going to add up. And for example, a green and a red would give us a yellow. All three colors would give us a white. That's the way we view TV. If you look at the TV screen with a magnifying glass, you'll see the three primary color dots. Now, however, if you are trying to print, for example, on paper, this is what you are doing. You are combining these colors, yellow, cyan, and what do you call it? I forgot what you call it. Okay, but you combine these colors to get the colors, and you see they add up to black. So it is different when you are dealing with print than when you are dealing with projection. And actually I must say I'm no expert with color, and I don't know much more than what I just told you, so for the artists among you, probably you know much more. Okay, one interesting thing that I would like to mention, when you add colors, you can actually, the way we paint them or the way we make colors when we use software, when you see web pages, for example, the way we choose these colors, we assign to them numbers. And the numbers are 0 to 255. Now, for example, when I have the cursor on black, you see it's 0, 0, 0. Now, when I have it on white, it is 255, 255, 255. I have it on green, it is just 255. If it is here, 255 and 255. So green and blue gives us cyan. Red and blue, I think this is what's called magenta. So 255, 0, 255. And so on. The yellow, 255, 255, 0. And so on. Okay, now if, for example, we are looking at this Mickey Mouse that has a white mouth, a red face, blue ears, and a black nose. If we try to view the mouse through a filter, which is essentially a piece of plastic that is red, in this case. So you see what's going to happen if we look through the filter. From the white light surrounding the mouse, the red is going to pass through. So it's going to make the face indistinguishable from the surrounding white. But then the other colors are going to be just blocked. The filter is not going to let them pass through. The filter is going to let only red pass through. If my filter is green instead, the white is going to pass green, but everything else is going to be black. Blue, same thing. The blue is going to pass, the white is going to pass, but everything else is going to be stopped. Okay, of course you can have partial filters, like most of the filters that you have in the market are going to be partial, so partial, they're going to block partially the other colors. Okay, now just the same idea here. What about if I have the mouse here and I shine only blue light? I'm going to see only whatever is white or blue. Okay, this is if I add green. Now if I add all of them, you notice there we couldn't notice the ears before because they were indistinguishable from the rest. Now we see them. There we got it. Okay, one last thing about this. Shadows. Now what I have here, let me make it a larger source. So I have an obstacle and I have a light source shining light here. You see the way we get shadows. The main part of the shadow is going to be here. We have partial shadows here, a little bit after that, and then you are going to see the actual color that you are projecting. If we use green, this is green and yellow, green and red, I mean. So it's the same thing. One thing trying to point to here, the actual shadow is black. That's a lack of color. There is no color. The color, you are going to see it outside of the shadow. Okay. Now, for example, here, all three colors are added somewhere here, giving us white. Okay, we're done with this.